Your feet are being stretched into a strand of spaghetti 1,000 miles long, while your head hasn't even noticed yet. This is what falling into a black hole actually does to you. So let's fall in, on purpose. You're floating in space beside a black hole the size of our sun. It isn't a hole. It's a ball of collapsed matter so dense that nothing, not even light, moves fast enough to escape it. Around it sits an invisible line called the event horizon. Cross that line, and there is no coming back. Not by rocket, not by light, not by anything. So you let go, and you start to drop. At first, it's gentle, almost peaceful. You're falling, but you feel nothing. No wind, no sound. Space is silent. The black circle ahead just grows and grows, swallowing the stars one by one. But look closer at that black circle. It isn't empty. Around its edge, the light of distant stars bends and wraps, smeared into a glowing ring. The black hole is acting like a giant lens, and it's bending the whole sky around itself. You are falling toward the one place in the universe where even starlight has to take a detour. Then your feet start to feel heavy. Here's why. Gravity gets dramatically stronger the closer you are. Your feet are a little closer to the black hole than your head, so your feet get pulled harder, much harder. The difference stretches you. Scientists have a name for this. They call it spaghettification, and yes, that is the real word. Your body is pulled into a long, thin noodle. Feet first, then your legs, then everything. You are turned into human spaghetti before you ever reach the bottom. And it doesn't stop at you. Your atoms get stretched apart too, the very stitching of your body unpicked, one thread at a time. But here's the part nobody tells you. While this is happening to you, someone is watching from a safe distance. A friend, floating far away. And what they see is something completely impossible. They watch you fall toward the black hole, but you slow down. The closer you get to that invisible line, the slower you move. Your falling becomes a crawl. The crawl becomes a freeze. To your friend, you stop, frozen, pinned to the edge of the black hole forever, like a fly in amber. Why? Because near a black hole, time itself slows down. The stronger the gravity, the slower time ticks. At the event horizon, from the outside, time nearly stops completely. And it gets stranger. Light coming off your body has to climb out of that gravity. As it climbs, it loses energy. It stretches and reddens and dims. So your frozen image doesn't just freeze, it fades. You turn red, then dark red, then you simply wink out, gone, without ever crossing. So to your friend, you never fall in. You hang there fading for the rest of time. But that's not what you feel. For you, there is no freezing, no slowing. You sail straight across the event horizon and you don't even notice the line. There's no wall, no barrier, nothing to mark the most important boundary in the universe. You cross it the way you'd cross the equator. But do one thing on the way down. Look back up. Above you, the entire outside universe is squeezed into a shrinking circle of light. And because your time has slowed, theirs has sped up. Stars race through their whole lives in moments. Galaxies wheel and burn. You could watch the future of the cosmos play out above your head and fast forward, the whole rest of eternity flickering by in the last window you'll ever have. And then the window closes. Two different stories, both completely true. One of you falls in seconds. The other watches you stay forever. That is not a glitch. That is how this universe actually works. Now you're inside. And inside a black hole, our rules break down. Here, falling toward the center isn't a direction you can resist. It becomes time itself. You can no more avoid the center than you can avoid tomorrow. Every path leads in. Forward is down. There is no steering wheel. There is no reverse. So you keep falling toward a single point at the very bottom. We call it the singularity, a place where all the matter is crushed into something infinitely small and infinitely dense. The truth is, nobody knows what it really is. Our best theories hit this spot and simply stop working. The math returns infinity, and infinity is science quietly admitting it has no idea. Maybe it's the densest dot imaginable. Maybe it's a door. Maybe it's the edge of everything. We genuinely do not know because no information ever comes back out to tell us. And that's the loneliest part. Whatever you see in there, whatever you become, you can never send a single message home. Not a word, not a photon. The event horizon is a one-way door for the whole universe. Your story ends in a place the rest of reality can never read. So here's the real answer to what happens if you fall into a black hole. You don't get crushed at the bottom. You get stretched on the way down, torn apart by the difference between your head and your feet long before you reach the center. For a giant black hole, that stretching is gentle at first, and then, very suddenly, it isn't. And the strangest truth of all is this: there is no single answer to when you die. Ask the person falling, and it's over in heartbeats. Ask the person watching, and you're still falling now, and you always will be. A black hole doesn't just end you. It splits your story into two versions that never agree, and then it locks them both away where no one will ever check. So, knowing all of that, if you had the chance to look over that edge just once and see what waits at the bottom of reality, even if you could never come back, never tell a soul what you found, would you take the fall?